This video is all about communicating across the internet from Unity. And there's actually a number of ways that you can communicate across the internet, and this video is just going to sort of introduce things, and other videos will explore them in more detail. And we're going to talk about two major things that you may want to do across the internet. The first is going to be web requests, where, for instance, you're pulling an image off of a web server to use in your game. And multiplayer networking. And these actually behave very differently. Pulling an image off of a web server versus doing multiplayer networking, they actually kind of use different technology, and they're going to allow us to talk a bit about how the internet works at perhaps a more fundamental level than you may be familiar with. And we're going to see what we can do across the internet with Unity. Now, the first thing we're going to talk about is this www class. And Unity provides the www class so that you can request resources on the internet, and you can pull the results into Unity. And it can, just like it can pull, it can also push. It can send requests and send data to websites. So, for instance, many games have a backend server that they connect to say, validate users when they log in, to save game information, to report analytics so that the game can be analyzed and that can be used to improve the game. And the game server, when you use www, it has to have some kind of interface for you to connect to. And www works by making a request to a URL. So what you want to do with www has to have a URL to connect to somewhere on the internet, a web address and a path for it to work. So in this case, the web address that I'm connecting to is unity3d.com. It's in this docs subdomain, and within that server, I'm connecting to script reference/www. So this is actually, I could request the contents of this page using a www request in Unity. www is primarily designed for pulling in three kinds of data. It's used for requesting images, for requesting text, and for requesting movies across the internet. Now you can also send and receive binary data, but it's a little bit more work. For pushing data to a web server, so if you're going to save the state of your game, or if you're going to send a bunch of data to log a user into a web service, for instance, then you're typically going to send the data in a form. And you can see here www form. And so you can actually, and there are some examples on here, but we can actually add some fields to our form with information, package that all up, and then send it with a www request to a website. Now, on the flip side, networking is also used for multiplayer games, but the technology ends up being very different. And what I have here are two of, just anecdotally, what seem to be the most popular multiplayer servers. So these are going to be the backend that help all of your users connect, whether they're playing a turn-based game like Civilization, or whether they're playing a straight heads-up Twitch reflex game like, say, Call of Duty. SmartFox server, and the other one is Photon server. And to understand how multiplayer networking works, we really have to dive a little bit deeper into the technology that actually runs the internet. We have to kind of understand what's going on under the hood. Now, when you're doing www requests, just sort of straight old requesting a web page or requesting an image or whatever else, it is just like you're requesting web pages in a browser. And so as you have seen in your days and years and whatever of using the internet, every time you request a web page, it puts this HTTP or HTTPS right at the beginning. And HTTP and HTTPS is a protocol, and it's a protocol we use for talking to web servers and either sending or requesting information. So you might send information when you log into Facebook, you might request information when you load a video on YouTube, although in both cases you're both sending a request with some data and you're getting a response back with some more data. Now when you do multiplayer stuff, on the other hand, you don't work in HTTP. You typically work with something called sockets. And sockets are a connection between you and the server that live in a lower layer of the internet. And they live in a layer called the transport layer. And you can actually see that over here. So when we request web pages, we're typically going to work in the application layer. And the application layer has HTTP. It has other things that you guys have probably heard of. For instance, FTP, SSH, things like IMAP and SMTP. These are the protocols that you use to send and receive emails. So this is a protocol that like Gmail might use. I've previously used POP and LDAP. LDAP is Lightweight Directory Access Protocol, and there's all these sort of things that different applications use to communicate over the internet. Now the transport layer is a little more fundamental, and the transport layer essentially is a way of wrapping up data. So for instance, TCP is a protocol in which you can stick a chunk of binary data. UDP is another similar one, and there's a bunch of other ones. And the application layer is built on top of the transport layer. So sort of inside these requests, we have these requests. And under the transport layer is the internet layer. And the internet layer essentially tells us how to get around the internet. So I'm sure you've heard about IP or maybe TCP IP, and that's actually the IP address of a website is numbers that tell you how to access that website. So at the very basic level, you have to know where you're going, then you have to send some data, and then the application layer adds all of this extra stuff. So here's where we send our binary packets of data. And with, for instance, HTTP, you're actually sending things like headers, for instance. So when you contact a web page, you send it information about the information you're sending. So, for instance, and there's a whole bunch of these headers. So, for instance, you can send information about cookies. One of the most common things is going to be content type. So you're telling it what type of data that you're sending. So you might be telling it that you're sending it a JPEG or that you're sending it text. So for instance, text/plain is a content type. And there's just all these various common headers. And in addition to that, for instance, when you request something from a web server, it might send you back a response code. And I'm sure you know that 404 as a response code means the page that you're looking for was not found. Even if the page returns totally correctly, you may not know this, but a code of 200 means that everything was okay. So it'll send back the data you requested, and it'll send headers, and it'll send a response code, and there's all this other stuff that lives within the HTTP layer. And most of the time, that is fantastic for us because it gives us a lot more information. If in Unity we're trying to request an image off of a web server, we want to get that status code back. We want to know if we weren't able to get the image, why weren't we able to get the image? Is it because there's a temporary issue? Is it because the image wasn't found? Is it because we have to log in first and we didn't supply the proper credentials? What's the reason? And then the response field can tell us what kind of data we've gotten back. So that stuff is all very useful. But when you're doing multiplayer games, on the other hand, you don't care about any of that stuff. You want to connect as quickly as possible. So you go down a layer, you drop off all of that extra stuff, and you just focus on sending packets and streams of binary data. So you compress your data as much as you can, you stick it in packets, and you send it across the internet to your multiplayer server, and then it sends information back to you. So that's kind of the fundamental difference between how, for instance, Photon works, and SmartFox, to do multiplayer stuff, and how this www class that Unity provides works to help you make requests to web pages. Now, there's a few other topics and things that you kind of need to know about when you're sending things over the internet. When you're using www requests, typically you're going to be connecting to some kind of interface on the server. So basically, the server that you're connecting to has to have some way of processing your request, doing whatever you're asking it to, and returning the result. And the interfaces that you work against, there are certain standards, industry standards. From what I've seen, the most widely used one is called RESTful. And RESTful is a type of web API, and I honestly never remember what the acronym stands for. Let's see. Alright, I went and looked it up for you. Apparently REST stands for Representational State Transfer. Now, as far as you're concerned, at this point, it's basically just the interface that you're going to be connecting again, and it has certain rules for how you send and receive data. In addition to REST, there are also other protocols. For instance, SOAP is another one. And you'll learn more about these other places. And in addition to understanding the interface you're connecting to, you also have to understand how you can send data. And you can certainly take your data and convert it down to binary. We know that everything under the hood is binary, so we can take it to binary and send it across the internet. But often we want to structure it in a bit nicer of a way. And there's a couple of main ways to do this that you may actually be familiar with. One of them is called XML. And XML, Extensible Markup Language. This is, if you've ever made web pages, HTML is kind of based on XML. So let's see if we can find a quick example of what XML looks like. So XML has open and closed brackets, and it has nesting. So this to, from, heading, and body live within this note. So XML is a way of packaging up data that's sort of everyone agrees on. There's also another way called JSON. And JSON stands for JavaScript Object Notation. It was, of course, originally created for JavaScript, but once people started using it, they realized, wow, the entire point of JSON is converting objects into this form that can be sent across the internet. And every modern language is object-oriented. Every modern language is based on objects, so this is perfect. So JSON is going to be used in C#, it's going to be used in Java. JSON is probably used at least as much as XML to send data over the internet. Let's see if we can find a quick example. And JSON actually looks a lot like XML, only the syntax is a little bit different. So here we have the name glossary, and then we have open brackets and close brackets, and that tells us that within this we have an object. So within our glossary we have a title, and so on and so forth. And from what you've done programming in C#, this may actually look somewhat familiar, this sort of open and close brackets to organize things way of doing things. So this is probably why so many programmers prefer to use JSON, especially people that work in C# and Java and those type of languages. And here's the same information expressed in XML. So you can see that really they have sort of benefits and drawbacks of each. But you can express data either way, and that's how you can send data across the internet if you don't want to send it as binary. So that's a lot to digest. So let me do a quick rundown again for all of these things that you're going to, at some point, need to understand if you want to do a lot of networking for your games. And coming back to the beginning, we talked about that there are two ways really that we're going to be accessing the internet and sending information over the internet. We're going to be making requests to web pages, and we're going to be doing multiplayer networking. And with requests to web pages, we're going to use this www class, and if we need to send a bunch of information, we can use a www form to wrap it all up. We can send information as JSON, we can send it as XML, we can send it as binary, but regardless, we are going to send it with this sort of HTTP protocol or some of the related ones, like FTP or some of these other application layer protocols. And we're going to have some kind of a website to connect to. We're going to have a web server. And we might connect to REST, a RESTful server. We might connect to a server that uses SOAP. And then we send our data, and the server gives us back stuff that we can use in our game. So it gives us back either, say, a go or no-go when a user attempts to log in, or it gives us back the top scores from previous players, or it gives us images that we can use in our game, all kinds of useful stuff. On the flip side, we have multiplayer networking. And that's what you're going to use SmartFox and Photon and these other services for. And these are going to work at a lower level. So if we go back over here, we're going to see that they work at the transport level. And we're just going to be sending packets of data, and we're going to be using sockets to connect to these web servers. And as we start to learn more about how sort of the internet works and how we do networking in Unity, we're going to have to understand a little bit about both of these layers, about how we make HTTP requests, and then how we send TCP and UDP packets across. And that will help us write multiplayer games, connect to servers, and do all kinds of cool things over the internet.